This is the beginning of experiment 7, and if we're on campus, I would tell you this is probably the best experiment that we have. There's so many great reactions, so many good things you can see. I've done my best to find some good videos that you can try and replicate that, so I really encourage you, watch all the videos. There's a lot of good chemistry here. Remember, whether you're Tuesday or Thursday lab, you've got your pre-lab data, post-lab, all that's due by the end of the day. Exam 1 will take me some time to get that back, 1.5 weeks typically. Please see me during office hours if you want to talk about the experiments, data, any of this, and I really encourage you, contact your lab assistant. That's Jamie on Tuesday or Kara on Thursday. You can do that by going to the discussion boards on Canvas, and they'll respond to you there. There's not a quiz this week, so again, it's really important to think about what if there was a quiz. What would be on that quiz? Would it be quantitative, qualitative? Would it be about procedure, safety? What are the things that I need to know? We'll talk about these things before this experiment. Mentioned, I think this is one of the best experiments. I get lots of feedback from students that this is great, but please note this experiment is really hard, especially when we're writing out the equations. Okay, so it can take some time, really allow yourself some time to do that. And we're going to get in that routine, experiment 7, 8, and then we continue on until experiment 12, and then another exam. So if you were doing this in the lab, there'd be really important notes. The board would be full of notes thinking about each of these experiments. But I want you to watch the videos and make observations based on that. You'll get to see a lot of this happen. Some of the notes that I do want to point out, even though you're watching videos, is how different gases react to a flame. So hydrogen will give you this nice pop. CO2 will go out. O2 burns a little bit brighter, and then air just gradually goes out. So if you see bubbles or you see this idea that there could be gas present, then you take a flame and you expose it to the gas and see what happens. The other substance that we haven't talked about in lecture, and that's these hydrate compounds. So you can see here there's water with this cobalt-2 chloride, and those get trapped in a specific number. There's 6 here, but you can heat it and get rid of that water. Okay, so that changes the properties. Well, you can add water back in, and that changes the properties. This is a really nice video. Encourage you to check that out. Part E, you need to be aware of the indicator. So we've used litmus paper to indicate some things for us. You add a little bit of an indicator, and then you can determine, is it colorless, or is which tells you acidic or neutral, or is it pink, this nice bright pink color, that tells you it's basic. Okay, so I want you to watch these videos because there's a range of evidence. Is it a gas? Is it a solid? Is it a color change? What's going on that maybe there's a chemical reaction? So that's the hope for experiment 7. Because we're looking at a lot of different reactions, it's important to be able to classify them. Okay, so you can classify reactions by what atoms do. And this is just looking at a range of atoms that could be combining. That's a combination reaction. Or they could be breaking apart. That's a decomposition reaction. So it's just the general symbols to show you about these reactions. Single displacement and double displacement. So this tells us if the metal's being replaced and this A is getting left out on its own. Or double displacement. They're both switching partners and everyone's happy about that. And this is typically a precipitation reaction that we see. So solids form. Combustion, you've done some of these before. It combines with oxygen, and sometimes you'll get CO2 and water, but this is a combining with oxygen. So octane in gasoline combines there. Oxidation reduction reaction, also you can think of it as a reaction that involves oxygen It's also an electron transfer reaction. Okay, so the most basic example given lecture is sodium metal, which is a solid, no charge, goes and reacts with chlorine gas, and that gets you your sodium chloride. Precipitation, I mentioned those double displacements. Neutralization, acid plus a base. It's going to give you a salt. That means some ionic compound and water. So these on the right side are chemical classifications, and these on the left side are what atoms are doing. So you'll be thinking about those as you go through experiment 7, looking at all these different reactions. I mentioned this is a tough part, okay? So this is one of the toughest parts in CHEM152. And you can see here, we've had molecular equations for a while, and you would need to balance those. So you can see chloride on the left, there's 1, there's 2 on the right. Okay, there's 2 nitrates on the left, 1 on the right. So if it's a polyatomic that's together, then balance them together. So that's 2 nitrates, 1 nitrate. Now I make that 2 nitrates. Okay, 2 chlorides, 2 chlorides, and then that's 2 sodiums, which is balanced here, and lead's already balanced. So that's the molecular. Well, the assignment will also ask you to do the complete ionic. This is very difficult. You have to understand charges, okay? So we have to know our polyatomic ions, and if that's known, that's nitrate minus 1 charge. There's 2 of them. That means that is lead 2+, okay? And that's in solution. And just knowing the ions helps, but we also have to know how to use these subscripts. So if this is a subscript, it's telling us that we had 2 nitrates. So now that comes out front into a coefficient. This coefficient gets distributed to both, because that's 2 sodium chlorides, which means there's 2 sodiums in there. And there's 2 chlorides in there. And it takes up a lot of room even. Look at this, I'm using half the screen here. Okay, make sure the precipitate stays together, so you do not separate those out into charges, but you definitely do for this soluble substances. So that's our complete ionic. Okay, you'll have lots of practice on this on experiment 7. Definitely encourage you to work on this. Email, come to office hours if you got questions. This is hard. So the last question then is, what's the net ionic equation? Okay, really what that boils down to is what's actually happening. Where's the chemistry at? So you can see right here, nitrate, 2 of them, nitrate, 2 of them. They didn't do anything. Okay, that's like a math equation, 2x on one side, 2x on the other, just cancel it out. Sodium doesn't do anything. Doesn't do anything. Cancel it out. So the chemistry, what actually matters, what gave you this great observation, solid being formed, is the lead reacting with the chloride, giving you lead 2 chloride. So I encourage you to have fun with this experiment 7. Like I said, there's a lot of good stuff in here. Come see me if you get questions.